Okay, can you hear me? Everything is fine? Nice conference, isn't it? Very good. I really like it. It's my first time in Russia and in Moscow, and I really like the city so far. I only had one vodka yesterday, so it's okay, but several beers. Okay, so I want to talk about data science, and this is of course a bit of a exotic topic on a DevOps conference, but let's see. So I handed in my CFP and it was accepted, so maybe it's interesting. So it's called Data Science, the New Troublemaker in the Delivery Pipeline. Just a word in the beginning, it's not a real technical talk. So delivery pipeline here has nothing to do with Jenkins pipelines or things like this. So it's really about the value stream of a company. Okay, let's start. So I'm not very egocentric, but this picture is actually a part of our company slides template, so I used it and I thought, okay, if there's a picture of me, it should just show this is like a normal standard data scientist looks like, so it's me, I'm a standard data scientist. Yeah, so Blue Yonder, the company I'm working for, it's in one sentence maybe something like a data-driven software as a service solution for the retail industry. So mostly brick and mortar supermarkets or online shops, and we are doing replenishment, so ordering stuff for them, or doing dynamic pricing. And we are doing data science even before it was called data science, so it stems from all the CERN physics stuff. Yeah, I'm working since 5 years at Blue Yonder. I'm a data scientist, and now I'm working, that's why I do this talk here, on a team which aims to increase the efficiency of all our data science customer projects. So that's why I'm talking about what's so hard on doing this data science stuff. So the agenda. First of all, I don't know if everyone knows what really data science means, and I have a very special definition here, so watch out. Then why is all this data science and also big data stuff so important? And then why is it so hard to integrate? So why is it a troublemaker? And then I also want to give you some ways to successfully integrate data science. Okay, so what is data science? There's the big data Borat, and his tweet was, data science is statistics on a Mac. It's of course a joke, but maybe there is some truth behind it, because there's another definition, and this goes a bit in the correct direction. So a data scientist is a person who is better at statistics than any software engineer, and better at software engineering than any statistician. So this is maybe the best definition of what data science is. So we combine software engineering with statistics. My definition, so I thought, yeah, okay, so maybe let's put it in one sentence. Data science aims to build systems that support and automate data-driven operational decisions. Maybe read it again. So the surprising thing here is it's about operational decisions, and that's what my talk wants to point out. So if you take home, data science is about decisions, then you learn something new, and you can have a new fun fact for other people. Yeah, I have. Maybe you don't get it right now. What is a decision, and what does it mean? So let's just look at an example. So one question can be, what is the optimal price for the clementines today? So really, okay, those above here, the price is $2.49, but there are other clementines down there, $2.99. Is this really the optimal price? Or maybe on a Monday, should it be cheaper? Maybe if they already look a bit, vergammelt, maybe they should be cheaper. So these are questions and these are decisions someone has to make. So what is the optimal price? Another thing could be, so in our business, the retail industry, how many apples should we order for next week? And actually those are fancy apples. Okay, so how much do we order? I don't know. Then why is it so important? The important thing here is operational decisions like setting a price or ordering stuff done by humans are suboptimal. And why is this? There are several reasons, but one reason is we have various known biases in our brain. So our brain is really not a good machine. It has some flaws. For example, this picture is from Wikipedia. There's a list of 150 known biases, so where our brain really does the wrong decision. For example, I have 3 examples here. There's, for example, the bandwagon effect. So these are things one might know. So, for example, there's the tendency to do things because many other people do the same. For example, if you later on evaluate my talk, if everyone clicks on green, you will click on green too. It's good for me and it doesn't hurt you. But for example, this might also be if everyone around me is electing Trump, voting for Trump, I do the same. Confirmation bias is kind of similar, is the tendency to focus on information in a way that confirms one's preconceptions. So it's just, oh, if I think on Monday it's colder, then I would just neglect Mondays that are warmer. It's just like that. So we filtering out stuff, and it's really biased. So it goes always in one direction. Yeah, that's of course a really bad one, neglect of probability. That's, for example, if people are afraid of flying. So if they would calculate the probability of dying in an airplane crash, it's really much lower than entering a car. So you should be more afraid of entering a car than a plane, but yeah, we cannot calculate with those tiny probabilities, so we completely neglect them. Then the next thing, of course, is humans are lazy, and that's not even bad, it's good. So we need to sleep sometime, we cannot work 24/7. So yeah, but each and every of these decisions should be optimal. So it should be the optimal price for the clementines today and tomorrow and so on. Not making a decision at all, being lazy, chilling around and not doing a decision, for example, let's just take the price from yesterday, is suboptimal. Simplifying the decision making is also suboptimal. Oh, I need to consider the weather. Oh, it's so hard. I just take the price from yesterday. That's bad. That's suboptimal. So, and also that's another point. So, these optimal decisions are getting more important year after year. And why is this? The competition in each industry is getting harder. For example, online. Everybody knows Amazon, and yeah, companies like these increase the pressure dramatically. So the markets get more transparent. You can search everywhere for the same product. You can buy it where it's the cheapest. It gets global, so you can buy from everywhere, from every country. And also digitalization, that's the same effect like for Amazon. So even if your company is 100 years old, maybe that's even bad, because then there's a new player with new technologies and he can catch up very fast. So he can build up a new company very fast. For example, Tesla is one of these examples. So they are in principle an IT company. They are not a manufacturer anymore. And this sums up in numbers like these. So German retailers, for example, Aldi or Lidl, companies like this, it's not really clear, but somewhere around 1 to 2% at maximum is the margin. So for each euro they earn, they only have 1 cent left. Now reconsider the clementines, 2.49 the price, so increase it to 2.5 would double the margin here. So it's really crucial to have the optimal decisions here. Now summing this up just means, okay, with data science we can address all these issues like suboptimal decisions, not doing decisions at all, and we need to have better predictions, better decisions to stay in the market. So data science is unbiased, at least if your algorithm you write is unbiased, but you can do it. You can use every information you can have. you can do arbitrary complex computations for the good and for bad. Automation enables to optimize all decisions. That means the lazy factor is gone, so we can set prices each hour if we want, for each individual product. Yeah, and of course we can actually do these decisions. Now, why is it so hard to integrate this data science stuff? So we saw, okay, it's really important to introduce this data science because of all those things like, yeah, better decisions and so on. But now I want to show you why it is so hard, because people, this here might be a quite common dialogue. So someone says, two CTOs meeting at a golf course. Are you already doing this data science stuff? Yeah, we have data scientist team since 1 year, but the progress is really slow. We have no results yet. This can be, and we have many customers exactly this happens. So 7 data scientists sitting around, but nothing happens. So there are no decisions coming out. And I will explain you why this is the case. So this is, okay, I have to excuse, so I haven't found a good picture, so I draw it for myself. So this is why it looks like this. This is a typical data science workflow. Maybe you know already what it is about, but I will explain. So what you do here on the input side is you take all kinds of data sources you can think of. There's the enterprise resource planning software, ERP, or this is point of sale, means the cashier in a supermarket, or credit card payments and things like this. You have customer relationship management, maybe data from your online shop, like click streams, things like this, or even unrelated things like weather, or what you can think of, any kind of thing. Then you have some kind of extract, transform, load step. So you pull all those data sources, wrangle them, transform them until it has a shape like this. So this should be a normal table. So you have columns with names, like a table in a database, and you have rows. Rows is the historic data, so it means the sales data from years before, or the prices from years before. And then you have this black box called machine learning, and for most companies, of course, this is a black box. Only the data scientists know what's in there, so everyone will consider this as a black box and no one will ever look into it. Everything the company sees is we have to put this table inside, and then there's decisions coming out. So that's data science workflow on one page. Of course, these decisions that come out, they have to be integrated in some way into the IT infrastructure of the company, like going back to the enterprise resource planning, like SAP or things like this, or in a data warehouse, or maybe a big data lake, or whatever you want. Okay, so as you saw, this decision-making system, whatever it is, this machine learning, data science stuff, it is already deeply integrated in the business process. So you need to pull your business process data, put it in machine learning, you get decisions out, and they need to go back into the business process. So you cannot just put it somewhere beside and say, okay, it's doing this stuff over there. It is integrated in your business process, and that's the whole big issue here. For example, on the input side, there are many problems. For example, just data availability. It needs to be available in machine-readable form. Means somewhere in a database, things like this. A sheet of paper lying around somewhere on a desk is not so good for machine learning. It needs to be as real-time as possible. Why? We want to predict the future here, so it's not good to have years-old data. We really need data from yesterday, at best, or from a minute ago, or whatever. So just you need as real-time as possible. You need consistent data. This means you have to sync all these data sources. For example, if one department does his stuff always on Monday and the other department always on Friday, and maybe the other department just monthly, it's really hard to relate these data points together. So maybe you need to change your process here. Data quality, of course, is a huge factor, and that's the biggest problem for our customers, for example. So we need the raw, unaggregated data. Many customers already aggregate their data, for example, just store monthly data. Okay, that's not the data we want. We want, in the best case, we really want to have the, how is it called? I don't know. So the bong which comes out from a cashier system, I don't know. So really what each and single customer bought, that would be the best. But of course it's huge data you have to store. So it's not every customer is able to just store this unaggregated data. Data quality, that's also it's one of the biggest issues. So it's still humans sitting on a computer typing in the data. Yeah, many errors here and typos and missing values, and I forgot to write it down. So that's a big issue. On the output side, it's the same. We have a potentially huge amount of decisions. We will see some numbers later on. We need to validate this somehow. So what we are doing is automating these decisions. So once they are out, they will order stuff. And it's maybe not a good idea to just let the automatic algorithm order millions and millions of products. Maybe you want to have at least some monitoring, alerting, or some human approval at latest. So just to check, okay, we don't order all potatoes in the world. Yeah, and that's also, it's quite often forgotten. If we automate these decisions, they also need to be able to trigger real actions. For example, we have supermarkets and they say to us, we want dynamic pricing. Okay, do you have digital price tags? No. Okay. Millions of price changes every day. How do you want to do it? No. Okay. So this is something you need to consider. You need to, even in the hardware, invest and change your whole company. Yeah, also automated ordering process. It's not a standard in these industries. For the software developers, they know what coherence is, so that's why we don't want to use global variables, for example. It's the same happening here. It's the biggest problem for data science. There's even a paper from Google. It's called Technical Debt Data Science, or Machine Learning Technical Debt, tralala. It's really, that's the biggest pain point. Because we need data from all the different departments here, so sales or even promotion. So marketing has to deliver what's the plan for the next promotion for this product. This means we need to agree on common, for example, IDs, so that every department has the same ID for stores. Not that one has just the names, the other one are using numbers, and the other one have their own numbers. We need to have common data types, a string, integer, things like this. Yeah, and synchronize the data flow. A big issue are data dependencies. If you have your database admin, he will at some time probably change something in his data. Once you have integrated this in your whole business process, he cannot change the data anymore, because there might be a machine learning algorithm depending on this single column. For example, if you want to clean up some data, he cannot clean up the data because we need the historic data, for example, for the training. So it's not like years before, oh, okay, this is 3 years old data, we just delete it. No, we need it for the training. So big issue. And it's from the whole company now is a mess. It's like a wool thing. It's now entangled, and no one can change things anymore if it's done wrong. Yeah, data science is greedy by nature. This is a famous quote I invented just for you. The current database should be sufficiently sized for the next year. That's exactly what no data scientist ever will tell you. That will not happen. Now, the bad thing is he's completely right. He is right in that database is too small because, in general, the quality of his data science stuff, so the quality of these decisions, will get better with more features. This means more columns, more data sources, with more historic data, more years, with more different and independent data sources from different departments or even from weather, stock exchange, social media. Now consider you have your production system running, and then the data scientist comes around the corner and says, and now we need to access to the Twitter fire hose. Is it possible? Really? Yeah, and of course, just the computing power, the complexity of the algorithm. If the algorithm is more complex, in general, it has the potential to be better. For example, this is this deep learning buzzword thing here. So all of a sudden, you need a Google scale data center, and still it runs for months for one training. So you need a power plant just to calculate some stuff here. So it's not really to blame the data scientists that they are greedy. Data science in itself is greedy. So it's, yeah, just remember this. Of course, this means data science is also very, very resource intensive. I put up some numbers. So for example, the first step in a machine learning workflow is the training. So you give it all the historic data, then you do your training. Here, for example, we want to predict the demand on a daily basis for a supermarket. So we have 100 stores, 5,000 products. That's a small supermarket. Most of supermarkets will have more stores and more products. 3 years of history. That's also, it sounds like, okay, it's 3 years. But if you want to, for example, predict Christmas products, you only have 3 times Christmas. So it's statistics is 3. So for the statisticians here, it's not that much data. Just as an example, maybe 50 features. This means we have 50 columns in this table. And for example, some sales aggregates like moving averages or minimum, maximum variance, things like this, or some product details, the weather, the Twitter fire hose. This all goes in here. This sums up. We just multiply this to 500 million rows. Oof. That's quite a big table, and you cannot just split it trivially up. Most of the data scientists will come up to you and say, okay, I need one machine with one where all this data fits in. So it's roughly 200 gigabyte. I just calculated it with double numbers, so maybe it can be even more. Of course, sometimes you can compress it, but yeah, and it's a small supermarket and only 3 years of data. The same happens then if you already trained your machine learning algorithm, then you want to do daily predictions. So you do not need to train anymore, but then you want to do these decisions. So we have again 100 stores, 500 products. This time we want to have 2 weeks of forecast horizons. This means how much do we predict is sales tomorrow, the day after tomorrow, things like this. So this sums up to 7 million predictions every day. And you need to write this into your enterprise resource planning software like SAP. Just, I don't know, you can try at home at your company, try to write 1,000 writes per second. And even then it's 2 hours, so if you want to do it daily, you only have 24 hours. So even, for example, if you would add another 5,000 products, it gets already then, okay, it will not finish until our orders have to be sent to the manufacturer, for example. Big issue, of course, is security. This is what hits you at day one, because data is something you have to secure somehow. So for example, questions like, okay, we have those 5 new data scientists. Now they want to have production data on their laptop to do analysis. Really? All the customer data on their laptop? Maybe we should encrypt their disk or something like this, or maybe they are not allowed to do it, but then they cannot do analysis. Even different departments sometimes are just not allowed from a business perspective to see different data. For example, if their bonus is calculated on these numbers. Anonymization of restricted or personal data, it's enforced even by law. So you can go to jail if you mess up here and you, for example, pull together personal data which you are not allowed to. You need to establish fine-grained access control. A simple firewall like before, you just have your database, you put a firewall around and you say, okay, this is no one can enter here. It's not possible because we need this data. But then maybe you need to come up with some fine-grained access control even on data. So these columns are allowed to be used by the machine learning algorithm, but these are restricted and they are not allowed to read this. This is of course a big issue. Resilience and failure. So what happens if there are no decisions made, so no price set or maybe no orders? Is your business going down? And I would say the easy answer is yes. We integrated this thing deeply in the core at our business. So if this goes down, the first guess should be yes, our business is going down. So you need to come up with some measures against this. And this is what we are talking about now. So now we know, okay, big trouble here on the data science side, but it's important. So we need to find ways. And that's why I'm here on a DevOps conference. The way to come over this big trouble is exactly the same like the DevOps thing. We have the same buzzwords here, like alignment, silos, delivery pipeline, value stream. Most importantly is this lean thinking here. So try to have small and quick changes with focused value to the end customer. That's what we are talking about now. So the most important thing, and that's something the whole company needs to understand, except the data science, if you really want to do it. If you just want to have some plots showing nice dashboards, okay, but I'm talking about the real data science here, so automating business decisions. You need to accept that this is part of your value stream. So if you are a car manufacturer and you want to do data science, then it's part of your delivery. So it's the same like building the car. In return, this is the side for the data scientists. This effort should strongly focus on the added value. So this means evaluate the costs of this data science and compare it to the added value. This is the same like everything. So if we want a new feature for our online shop, we evaluate what's the return of this new feature and how much is it how big is the investment for this. And the same accounts for data science, but this is not done most of the time. So every time we see data science at customers failing, it's because of something like this. So you just give some people some money and you say, okay, do it, but that's not how it works. You need to compare the return and the invest. Data science is not a self-purpose. And I've never seen something like this working if you have a siloed data science team. So everyone is working for his own and then there's another department and these are the data scientists. This will not work. I mean, it can work, but most probably you have the same issues like the dev and the ops silo thing. 5 minutes, okay. Yeah, I will try. So most probably if in your company your manager says, we have 5 new data scientists and they are sitting in the next building, you could just say, okay, we most probably will mess this thing up. Also, the last point is very important. this is now part of your delivery pipeline. So you need to apply the same quality standards. Testing, quality assurance, pair programming, coding guidelines, things like this. So it is the same like every other IT quality standard here. And that's also failing very often. So my suggestion is always, so that's my rule number one, and I apply it to everything. I have written a new Ansible script, and it can, I don't know, it has checkpoints and is 10,000 lines long. I would say, okay, no, it's too complicated. Everything you need to do is keep it simple, stupid, but it's of course very hard. But yeah, that's important. Someone knows Occam's razor? Heard already? Okay. So this is a measure to address the resource problem. So it says, among competing hypotheses, the one with the fewest assumptions should be selected, and I translated it for the data science field. If the output of two data science models are compatible, take the one with smaller resource footprint. So this is how you can compare, how you can shrink the resource greediness of data science. You have to evaluate what's the value, and if the value is in the same region, take the one which has less resources. So this should be the main thing your data scientists should address. So they should know what's the compatible, for example, a less complex algorithm, or if we just use half of the historic data, they should know how much is it increasing the added value. Then for the data entanglement, there is the need to know principle. Normally you would apply this for your security, so you just say you give only data to those people who need to know it. So the main problem is, of course, the data scientists will complain and say, okay, we cannot apply the need to know principle because we need to know everything. And they are right, of course, we know. Their quality of their machine learning will get better with more data resources. So my suggestion here is do it in an agile way. Prepare a one-time excerpt of the data, maybe with just few people accessing it. Then evaluate the impact of every single data source. And based on this evaluation, then decide for each single source. So this might be an approach where you can have both. So the data scientists can have everything at the beginning, but then you throw away everything you don't need to know. Digitalization, get human interaction out of the loop. That's also the DevOps thing more here. So people can get really, really annoyed if you come with a new technique and you should now, instead of monthly count your products in the shelf, now you need to do it daily. They can get really annoyed. So maybe think of digitalizing these kind of things like with sensors or RFID. Just think of before the person on the point of sale typed in all the stuff, now they have laser scanners. And of course laser scanner data is just better, and it even helps the salesman. Also streamline the data handling, so think of APIs. Do not exchange the data here with emails and send it to the data science department. This would be the biggest fail, and I can predict it will not work. Also agree on data formats. This is something, modernize your IT infrastructure. It's not really, it's not one and zero thing here, but in general, I would say traditional IT is still built for human operation. This means you have many GUIs where you click your new database, things like this. So this just sums up to change is expensive. So if you have a very traditional thing, change is expensive. This also means you have a homogeneous architecture, like one big database, Oracle, and nothing else. And if you only have this Oracle database, most likely you will use this Oracle database for your machine learning algorithm, and that's maybe not the best thing to do. Okay. So yeah, there's a tendency then to use the wrong tools. So try to rethink. Maybe modern architectures, they are more or less a bit more decentralized and heterogeneous. For example, something like event sourcing. So yeah, it's just an example here. So think of modernizing your architecture so that you can use the right tool for the right thing. Maybe you need Hadoop and you need the data in both Hadoop and your Oracle database. Think of how can you transfer the data on a daily, regular basis into your Hadoop stack and things like this. Yeah, so that's my last slide. So here's my general roadmap. So take this to your manager and maybe you have a better chance then. First, start with defining the problem. Most important step. Which decision should be automated and improved? And if the manager will say, we don't want to automate decisions, then you say, okay, it's not data science then. This is then a business intelligence, things like this, reporting or dashboarding, but I would say it's not the thing I would call data science. Then, if you found out, okay, we have a problem with waste, so we need to automate our ordering decisions, and we need to get them better by 5%. Then, maybe hire some data scientists, but do not put them in a single team, but put them in a cross-functional team, which aims to build this decision-making system. So, this team builds the data science decision-making stuff. And then, like in the normal agile or lean way, measure and extrapolate the impact of the delivered improved decision. So how much better is it now? Then define if it so the best would be if you can evaluate this in real euros or ruble or whatever, so in real money. So it's improved by $5,000 per day. So that's then a number you could say, okay, this with these costs, then you can evaluate how much resources to put on, how much human resources, and then afterwards just do the normal cycle, improve, measure, and so on. So that's it. So what you take home, data science aims to automate operational decisions. Everyone got it? Yes, okay. It has a big and growing potential, so we need to do this kind of stuff, and each and every company will have to do it at some point. Data science is greedy, so we need big machines, yeah, and it increases the entanglement. That's true. But so we need to accept that data science is part of the value stream. So align your data science effort with the company goals, very important, and of course compare the costs with the actual improvements. That's it.
Okay. Any questions?
Thank you.
Есть ли у вас вопросы? Thank you very much.
Yeah, we are hiring, so is someone interested in doing data science at scale?
Вопросов нет?
The question, please, in English.
Hello, thank you for a very interesting lecture and a very gracious use of Occam's razor. And I have two questions. On one of your slides, it was said that data science makes optimal and unbiased decisions. So the first question is it really decisions and not decision helping? So data science makes decision itself, somehow automatically, I don't know. Can you give an example?
So data science itself, of course, it's not that it's unbiased or optimal, but at least you have the chance to have it unbiased and optimal. And also maybe I simplified a bit. Doing decisions often means you have to give some trade-offs. So machine learning maybe so you have some predictions and they are hopefully unbiased. But then you need to have some business decisions which then defines what to do. For example, you can have either empty shelves, and this might be a good idea because you do not throw away things, but if someone comes to your shop and he doesn't find what he wants, it's also bad. So it's not. It's a choice you have to make. You want to have full shelves, so every customer gets what he wants at every time of the day, or he doesn't. So it's a business decisions. It's a business strategy, which decision to take. But the data science prediction in itself, hopefully, is unbiased. Maybe I didn't get the question really, but
Actually, it was a second question, and you already answered it. Thank you. First question was, it's still a human who makes a decision, and data science just helps him, right?
we can go the full mile and automate also the last decision. Not the strategy, but we can automate this operational decision, like what price is the optimal price. This we can do with data science, and we can show it's most of the time it's better than any human.
And it's real now already. It's used.
Yes, it's real.
Thank you.
Thank you very much.